All right, guys. All right. Let's make that go up a bit. Testing 1 2, testing 1 2. Not too bad. Now. Hey Andrew, how are you? Can you hear me okay, or do I need to somehow make my volume louder? Cool. Thought I'd do another video here. I'm going to try and do one maybe every week. Right now, I'm just down in my shop and wanted to do a little bit of... Actually, I'm going to turn this so that I'm not looking sideways. See if I can get in a little better. I got your email, the one where you said you were upset you missed the last live stream. I'm gonna go get something, guys. I'll be right back. You're gonna like this. Wonder how I can turn. I can't see myself in the chat if... I don't know, I can't see my video at the same time that I'm chatting. I'm a total noob to this whole live stream thing. Oh, there we go. Default view. Now I can see myself and chat. So we have 7 people watching. Wow. Welcome, everyone. I wanted to do a second Q&A session. So I guess at this point, I hurt my back last week, guys, Saturday, a week ago. Holy crap. I bought about 80 pounds worth of new collet adapters for my mill back there. And I went to carry it out of the garage and ended up screwing up my back because I was trying to squeeze through a narrow area, and instead of carrying it sideways and waddling out like a duck sideways, I carried it in front and popped my back. So literally for a whole week, I have been down and out of commission. But today I'm feeling a lot better. I managed to get 1 scoop together last week. I'm hoping tomorrow I'll get more together. My son had a problem with his little air rifle today. When will I have a commercial product ready for sale? Hi, Chris. At this point, I've been working, building up all of the equipment for the prototype, getting my mill ready, my lathe ready so that I could produce parts, because I had received a $10,000 grant from Ben Franklin Technology Institute, but $10,000 wasn't enough to go out and have all my parts made. So I determined at that point I would make my own parts. And to do that, I needed to get my milling machine and my lathe tooled up and working correctly. So now I have a fully functional 3-axis CNC machine behind me. I have X, Y, and Z, and you've seen some videos probably where I'm cutting things out. At that point, I knew I was able to produce every part that I needed for this. So that's what I've been striving to do, because for the $10,000 that I got, I would have been able to buy maybe 2 or 3 sets of different parts, like my scoop supports and things like that. But if I messed up or if I didn't anticipate something, then I would have had no way to get more parts because I would have been out of money. So by making my machines whole and finishing them, I was able to now move myself into a place where I can be the manufacturer. I can produce the parts for my prototypes myself. I have 3, one of them is my son's, but I have 3 3D printers. You guys have seen them in other videos. I printed all of the gearing. I've got a whole pile of gears over there back on my workshop table. You're actually down in my workshop right now. So to answer your question, Chris, I'm looking to have the commercial product ready for sale. I don't know. It's probably going to be 9 months out if I can get the prototype done quickly and move into a funding round where I can get the company up off the ground. You know, I'm going to need to buy machine equipment. I'm going to need to hire some people to do the manufacturing and fabrication. I'm going to need to hire installers. We're going to also want to put them out in a couple beta sites. And I've had a lot of people asking, begging to be beta testers for Harmony vertical axis wind turbines. So I'm not afraid of not having sites to test this. We have the Masonic Village up here would very much like to test our wind turbines. They've been looking for a vertical axis solution for quite some time, and when I spoke to them, they loved what they saw, but I just wasn't ready. I didn't have a product ready, so you know, I needed to go back and finish the prototype, get the numbers. Once I have the numbers for everyone, then the you know, the turbine will speak for itself. Once people see the numbers, and I'm hoping they're going to be fantastic, I'd love to see us producing 1,000 watts of power in 10-mile-per-hour wind. So how many watts? I basically just said. I'm hoping to get around 1,000 watts consistent in a 10-mile-an-hour wind, because we have 10-mile-an-hour winds here average in Pennsylvania. And when I do the math on that, the average person is around 900 kilowatt hours a month. And when you break that down, that's like 33 kilowatt hours a day. You know, if you're doing 1,000 watts consistently in a 10-mile-an-hour wind, the wind's not blowing all the time. So, you know, you can't say, well, I'm going to produce 24 kilowatts in a 24-hour period. That's not going to be the case. But I figure if we can get 10 kilowatt hours on average per day over the month, dude, that's one third of your entire electric bill right there. And if we sell this for about $8,000, you're looking at a payback of less than 5 to 7 years. So I'm trying to keep it real. I'm trying to keep it in the realm of, this is something that a mom and pop can afford. In fact, after a year or two of having it, they're going to probably be like, wow, these things are really kicking ass. Let's get another one, honey. And then they'll get a second one. Maybe have, you know, one on one side of the roof and one on the other side of the roof. So it'd be pretty cool. So, Chris, a lot of people, friends and family, are helping me, but I don't have any, you know, other than the 10,000 that I got from Ben Franklin at this point. I am in the FedEx contest, so if you guys please vote for my project out there, go to creatingmore.com and you'll find the voting link. That would be great if I won some money from the FedEx contest, but we'll see. It's just a contest. No one is like on board. I haven't formed the company yet, other than, okay, let me back that up. I do have the LLC registered. It's a fully formed company, but I'm the only true person in the company at this point. My wife, obviously, you know, your spouse counts in the company, but, you know, she's got her own things going on. So right now it's friends and family helping me finish things. I'd love it if some of you guys were nearby and, you know, want to come over. If you're near Hershey, PA, let me know. So Chris, I have my working prototype is what I'm trying to finish right now. And I've done a very, very bad job at helping people understand where I'm at with the prototype, because for the last 6 months, people have been watching videos and saying, well, this is a scam. You don't have any data. If it was real, you'd have data. Well, of course it's real. It's just not finished yet. And when I finish it, then I'll get the data. So you missed what I said probably, but I hurt my back last week after I got the first scoop finished. I am looking tomorrow to finish more scoops and start assembling them in the scoop array. So there's going to be 5 stacks of these. This and its partner on the, you know, on the other side are going to make up one scoop pair, and then the next one up will be cocked at about a 36-degree angle from the one below it, and then each level it goes up, it'll be offset. So by the time you're at the top of all 5, it'll be a helix. And when they're fully opened and they're spinning, there will always be a scoop facing the wind at every single degree of rotation. So the size of my prototype, this is one of the scoop pairs. Okay, so there's going to be 2 of them. You probably haven't seen the videos if you're asking these questions, go vertical, but 2 of them are going to be about 4 feet wide, and then 5 tall. Will put it about 5 feet, maybe 5.5 feet if you account for, the scoop supports in between, 5 feet 3 inches. So the overall height, if you had this on the roof of your house, would be about 4 feet wide, 5 feet tall. And you could have the generator inside of your attic, in your attic trusses, and then all that's coming out of the roof would be the pole that the scoops are rotating on. If you have it in the front yard, the generator, think of it like maybe the size of a dishwasher. It would be sitting on a concrete slab on the ground, and then up, say, 10 feet off the ground would be the bottom of your first scoop. You don't want it hitting anyone in the head, so you'd want your scoops about 10 feet off the ground and happily spinning. This isn't like, something that you're going to need to put 300 feet in the air or 100 feet in the air like the other ones. I'm looking to keep this real. I'm looking to keep it practical, and I'm looking to produce good solid numbers for you guys, because that's what matters. Producing solid numbers that helps everyone, so that within the first couple years of owning this, you've pretty much paid yourself back on energy savings. Now, I don't know if anyone has heard of PreciousPlastics.com, but I'm putting a plug in for them because they are fantastic. They're taking scraps and recycling them, and then grinding up those scraps for various purposes. I'd like to get linked in with them to actually have them send me, after we get up and moving, have them send me their plastics from all over the world. We'll pay them for the plastics. The people that are doing it in third world countries, send them to us. We're going to use them to extrude the scoops. I'd like to make these fully injection mold, and then you would just see these little holes in my gears. Basically, we would attach, so the whole scoop would be injection mold, and then we would just screw with 6 screws or whatever, 5 screws, the gears that ultimately they'll be aluminum. Screw the gears on, and your scoop is ready. The really cool part is if a scoop breaks, it's replaceable for, $100 or something crazy. I mean, you can pop the gear teeth off because they're probably not going to be hurt, and put them back on the plastic extruded scoop, and reinsert it back into your turbine. So I'm making this in a way that is 100% maintainable by you. You don't have to have us come out and do it or anything. I mean, obviously we'll have those. Thank you, Chris. It would be nice if some people with real money got behind this. Yeah, I'll finish my sentence and then go on with a couple applications, but I'm making it so that you guys can use this. You can, in a few years, have your money paid back, so you're not sitting there waiting 30 years for a stupid payback on a wind turbine that doesn't make sense. I mean, what in today's world lasts 30 years anyway, for goodness sakes? So maybe 5 years you'll be paid back from your initial investment. Hell, after a year or two of having this and seeing the numbers it's making, you're probably going to get a second or a third one anyway. They're going to be beautiful. They're like a work of art sitting in there, spinning in your yard. They're going to be multicolored, or you could pretty much order them any color you want. They're going to be durable. They're going to make sense. They're not going to be noisy. They're not going to kill birds. They're going to be something that finally makes sense for the residential market, and that's what we're after. The other power platforms for powering things would be, I guess by that question, Chris, you're meaning, am I going to look at scaling up for grid or village size or city size? Sure, this could be scaled up to whatever size the materials would allow. It's just a matter of getting funding for something like that and making them larger and larger and anchoring them better and all kinds of engineering questions or engineering issues, but scaling something up's never been a problem for us. Over the last 100 years or so of serious, well, really probably only 50 years of serious wind development, scaling things up has never been a problem. Yes, I am definitely looking at boats and RVs. So, when I go down to the shore and I see hundreds of boats in the slips and they're all sitting there with this crappy horizontal wind axis turbine. I know everyone's going to hate me for saying that, knocking the horizontal axis wind turbines, but I sat there and watched them. They cut in and cut out and cut in and cut out because they have to cut out when the winds get high so that they don't destroy themselves. Harmony's not going to have to. It just begins to furl and closes itself up. It's running an algorithm that's constantly monitoring the RPMs, and when it gets above its fast, safe limit, it's going to start furling, and it'll start furling and keep furling until the RPMs drop to a safe limit. So let's say that limit is 400 RPM. It will, once it says, ooh, I'm at 420 RPM, it's going to start furling, and it'll start closing down until the RPMs drop below 400, which it deems as safe. And then, in this example, of course, it'll keep spinning at that furled state until it needs to maybe furl more because winds have gone up even higher, or the winds start dropping off, in which case then it would begin to open back up to its fully open state. 90% of the time, it's going to be fully opened. It's just going to be capturing as much wind as it can. But in those high wind situations, especially near the shore and stuff, you're gonna definitely want this thing to be able to furl up and protect itself. Areas where they have typhoons and things like that, it's probably going to be safer. Well, I can say it's definitely safer for this to remain spinning than to stop and hold still, because when you stop and hold still, all of the force is pushing on the same side of the shaft over and over again until it fatigues and breaks. By it continuing to spin, you're distributing that load on the shaft. It might only be open 10%, but it's spinning right through that typhoon. The Peace Corps has contacted me. They were interested in having these scoops put directly on water pumps to pump water out of sensitive areas, and I maybe even pump fresh water during power loss situations, because these would be ideal for high wind. They're not going to care if it's raining like cats and dogs on it. It's just going to keep, turning right through that crazy storm. And they loved it when they saw that idea. So, you could couple this directly with water pumping technology. You don't need to produce electricity with it. The patent pending is on both the scoop technology and the generator. And you guys are like, wait a minute, generator? You've never even talked about that, Chris. Well, I haven't talked about the generator except maybe 1 or 2 videos because I have to keep that secret for now. There's way too much to do with just developing the scoops and just getting them out the door. Once I start actually moving into manufacturing mode for the scoops and everything, and I get real funding, then we will finish the generator that I have also patent pending. So there's really 2 patents that are in the process right now of being written. For the last year, it's been a provisional patent, and just a month ago, I contacted my patent attorney and said, let's go with the non-provisional patent. So he is doing 2 non-provisional patents. One for the scoops that you see here in the scoop technology, the scoop array. The other is for my generator technology, which it's going to blow you guys away when you see it. If you think this is cool, the generator is just as cool as this. And I mean that wholeheartedly. When you see this and when it's coupled together, my scoop technology with the generator technology, it's going to take the market by storm. At least that's my hope. I think you're going to agree once you see it, but I can't release the generator technology yet. I'm sorry. I know people are going to hate me for that. I've tried the open source thing for 20 years, guys. It doesn't work. I haven't, I'm still in my full-time job at the hospital. I'm still working a full-time job to pay the bills. I need to be doing this full-time. I need to be doing what's in my heart for a living. And that's where I'm at. I'm forming the company Creating More, LLC, and it's going to be all about bringing technology to the public to help the public, the average little guy, not some big company and making empires even bigger and richer than they are. I don't care about that. I want to help you. I want to help your neighbors. I want to help your parents, your friends, your family. That's what I want to do. I want to help make the world a better place while we're doing it, while we're improving our status here, you know, as a species. So we can't, it's embarrassing how much good we could do and how little good we're actually doing. Thanks, Chris. I feel as though I missed a question maybe a little bit back here. No, maybe not. I think I'm up to date with the questions on here. I can't check out those links right now. Go vertical. Your prototype was 4 foot by 8 foot, only 60 watts at 10 miles per hour. Wow. All right, that is a little bit scary. I don't know what your prototype looked like, but I will check out your videos. I mean, I'm not going to sit here and tout mine's going to do amazing things, because I've never in my entire life done that. I build, I get my hands dirty and I build, and then I test, you know, and that's what I'm going to do here. So I'm going to build the prototype, I'm going to finish the prototype, and then I'm going to do the testing. The little tiny model that I had, the little handheld thing, that little sucker had a lot of torque behind it. You know, I know it was just sitting there spinning on a dowel rod, but it had a lot of torque behind it for that tiny little thing. I think this is going to perform really, really well. So we'll see. You know, until I actually get it hooked up and start testing it, I'm not going to know. And I'm not going to sit here and tell you it's going to produce this and it's going to produce that. I'm going to finish it, and then I'm going to report the results, no matter how good or how bad they are. And we'll go from there. You know, the other day when I did the video, I said I think I would start the backside of my backing material maybe an inch further back. I'm actually happy that I did it out front, because when I looked at my CAD drawings a little bit closer, when you get out here to the tip, there's just no support out there. So what I'm going to do is simply nip these tips off and then do every single one of my scoops just like this. So these tips will be nipped off, and I think we're going to be perfectly fine. I'm really excited to see how things nest together. I'm hoping tomorrow I can get maybe 3 more scoops done, and that would actually let me do immediately 2 stacks. So, you know, you would see, maybe I'll do another live stream tomorrow if I get that. But the first 2 layers would be complete at that point. I still have to work out the little motor that's going to run the furling and unfurling. That's going to be totally controllable by software. It's going to be monitoring the RPMs and open and close according to those RPMs. But for testing purposes, I would be opening and closing things so that we could see if we get better performance in specific wind speeds. So maybe at 12 miles an hour, it's a little bit better to be closed a tiny bit than fully opened, or whatever. That's the exciting part, when you can start testing that stuff and see where you're at. So for now, you know, the prototypes are going to be made out of acrylic and 3D printed gears, but obviously once we're into more serious production mode, then I'm looking to have these scoops 100% injection mold, and then these gears would be made out of aluminum. You just put in 4 or 5 screws, 6 screws, I don't know, and secure them on, and you're ready to rock and roll. Everything that I'm making is in a way that you can replace a scoop if one breaks or something hits a scoop. But even if the entire scoop array would break off, some tree falls on it or whatever, the cool part about this is you have your generator on the ground or in your, you know, attic, whatever, and it's protected. It's in a metal shell. It's, you know, going to be very strong, very durable. Nothing's going to happen to that unless, you know, someone drives into it with their car. So, so even if something happened to your scoops and they snapped off or broke off, you would be only looking at a fifth, an eighth of the overall cost of the unit to replace all of your scoops. That's the really cool part here. Unlike your horizontal axis wind turbines that are 80 feet in the air, if something happens to that sucker, 90% of the time, it's dead. The entire thing, you know, has to come down and be replaced, or it fell over, whatever. I don't know. I mean, I'm sure people are going to yell at me and say, oh, nothing happens in there that can't be fixed. But how the hell do you get it down from there? It's 80 feet up in the air. It's like a whole 2-day project just to bring it down, repair it, and put it back up. It would take you 15 minutes to replace a scoop, and that'd be it. 15 minutes and you're done, and you're back in action. And I'm not joking about that. There's some really cool stuff that I'm going to show you once I get this together of how to actually replace a scoop. You guys are going to love how these things go together, how easy they are to maintain, and the low cost associated with them. They're built to be economical. They're built to be durable. Obviously, the ones made out of acrylic and glued together just for the prototype. But when we're doing injection mold, they're going to be like a waste management trash can, or your big 90-gallon trash cans that you put outside by the road. Those things are, my God, they're like a tank. You can throw them around, knock them down, they blow over in the wind, and they don't even crack or get hurt. I'm not talking the little tiny tubs that lay on the ground and they're only a foot high. Those crack all the time. But the big recycling bins and trash cans from like waste management in our area, and I'm sure there's other ones in the other areas, they're good 1/4-inch thick material. Those things take a beating, and that's what we're looking to do here. We're looking to do injection mold for the scoops so that they're durable, and then you would just screw the gearing right onto them so that if your scoop gets damaged, you pop off your gears, which would be the expensive part, put them on your new one, and you're back in action. Replace the scoop in the array, and you're good. It's about all of the new information I have. Again, I have to apologize. I've been hurt for the last week. My back went out on Saturday, a week ago, because I did something stupid, and I have not been able to get down the basement and in my shop and finish putting more scoops together. So tomorrow I'm looking to get some scoops put together, and maybe I will do another live stream if I get that done and show you guys how I'd love to get the first 2 layers complete so you could see that. And I think that would really get some of you excited. Is there any questions at this time? I know we only have 7 people watching, so that's fine. It's gonna take a while for things to catch on, and obviously, if I don't have a finished prototype, people are less likely to be interested in it. I am surprised with how many people. Hi, Mark. I'm surprised with how many people actually watched the last live stream, so that's why I'm doing another one, and I'll keep doing them, weekly, or maybe even a fill-in here or there. Do you have a question, Mark? Wow, we had 9 people for a minute. That's a world record for Harmony via WT. Guys, fire away. If you have a question, if you have a comment, go ahead. I'm here for you to answer questions. Cool. Hey, babe. That's my wife, guys. Well, Mark, you're probably the first, well, no, I won't say the first one, but one of few that say, you know what, everything is explained well. It's funny because as people see the videos and watch the videos, they start to understand. But when they've only watched one video, then they have all these questions, and they're mad at me, and they're like, well, why aren't these available yet? And why don't you have data? But, I'm building it, guys. I'm building it as fast as my little wallet will let me, and time, because I'm still working a full-time job. I came up with the idea, believe it or not, about 8 or 9 years ago. I'm an Ancient Aliens fan. I watch Ancient Aliens all the time. And I was sitting there thinking, what is the point of, we always think that the yin and yang symbol is just this decorative thing. And I'm like, no, that came from something people saw. I firmly believe that we had very high technology here on the Earth thousands of years ago. And the yin and yang symbol, I kept thinking and thinking over and over again, come on, that had to be for something. It had to be for something. And boom, the one day it hit me like a ton of bricks. I believe it was wind turbine scoops. And so that's what set me on the path of figuring out how to make the yin and yang symbol turn into a wind turbine scoop. And that is exactly what I've done with Harmony. What's really cool is, I don't know if many of you have understood this, but as they go up, each level is going to turn and be offset from the level below. So by the time it gets to the top, it's a helix. It'll be 180-degree twist from the bottom to the top, so that as it spins, it's going to be like a piece of DNA spinning. So not only is it really cool to look at from the yin and yang perspective, but it's also going to be a helix. So this thing is, it's beautiful when it's spinning. The little 3 version, the pink one that I had, you can't really even tell that that's a helix because it's only 3 scoop pairs. When you have 5 scoop pairs, the difference between each scoop pair is only 36 degrees. It's 180 divided by the number of scoop pairs. So 180 divided by 5 gives you 36. If I had 6 scoop pairs, and maybe we'll end up with 6 or 7 or 8 scoop pairs, who knows? I had to pick somewhere to start, so I picked 5. That's 36 degrees apart. But a 36-degree progression lets your eye really see a nice helix as it's spinning. So this thing, it's going to be beautiful when it's spinning. And if they're multicolor, if you go to Precious Plastics and look at some of their cool stuff they're doing, I'd love to see these things in production. Every other house, every house, when you drive down the road, should have some of these in their yard or on their roof. And I think we can change society. I think we can change the status quo if we start working together to make a difference. It's about you and I and our neighbors and our parents and everyone around us, our friends and family, having better lives and helping the planet at the same time. I mean, if we're making clean energy and we're cleaning up plastic that's on the beaches and on the shores and in the scrap yards and junk yards, all at the same time while we're doing this project, to me, that's a win-win 360 degrees around. So, Chris, I hope that answers your question. I see the 4 thumbs up. What do you mean about the top moving when I don't want it to? The whole, are you calling the top the scoops themselves, like the array of 5 scoop pairs? Are you saying, are you calling that the top and then the generator would be the bottom? The Harmony is a very, very cool design. I was going to wait and show this to you guys after I got it built, but since you're on the live stream, I'll explain it to you now. The top and the bottom of the scoop pairs are going to be basically fixed to the pole that's transferring all the power down to the generator. So the top of the scoop pole, oh, I know what you're talking about. You're probably talking about moving and swaying. I don't know yet. I can't know that until I get into testing. I would say we can fix that by just going with a fatter pole if need be, or a more sturdy pole. Yeah, the swaying, okay. But if it comes down to it, you know, there's all kinds of solutions. You see guy wires out there where people run a couple guy wires down. I'd like to avoid that because we're not going to be 80 feet in the air. We're not going to be 100 feet in the air. We're going to be only 15, 20 feet off the ground maybe, and even lower than that. If the bottom edge of the bottom scoop pair is just 10 feet off the ground, the top would only be 15 feet off the ground. So we're not up that high. And a 1-inch cold rolled steel shaft is what I'm using right now for the prototype. It's big, it's heavy. I mean, it's crazy. I'll go get it for you. There it is, guys. I don't have nearly the strength to bend this thing, but, you know, it's going to take a lot to bend this pole. It's a 1-inch cold rolled steel shaft, and I think for the prototype testing, it's going to be way more than sufficient. There is no, at the moment, I don't have any outside support that, you know, that's really coming into the picture. this will plug down into, it'll kind of couple with the shaft coming out of the generator, or it'll lock down into the socket for the generator so that you could kind of just decouple the scoops in my prototype. Now, just in my prototype for testing purposes, so that I can throw it in the back of my pickup truck and maybe drive down the road at 10 miles an hour, 20 miles an hour and do various wind speed testing, or take it somewhere where it's, you know, to a wind tunnel or up to Chickies Rock or something, which is a local place in the area that has a ton of wind. But basically all I'm going to do is the cart on the bottom is going to house the generator, and I've had that in my other videos. It's just a standard off-the-shelf 1,000 watt generator. Probably going to do a 4-to-1 ratio. Every rotation at the shaft will be translated to 4 rotations at the generator, and then that's going to be the generator cart, if you want to call it that, is going to be locked down to the ground with some short, you know, either ropes or something and some stakes into the ground, because I'm going to have to hold that sucker still or it's going to want to tip over. So that's going to have to be anchored to the ground, but that's just the prototype unit. In production, the real true production units, think of something like your dishwasher bolted and anchored to a concrete slab on the ground. It's not going anywhere. And then out of the generator, you're going to have a nice strong, you're probably going to have a very large, maybe a 2-inch diameter shaft coming out of the generator. And then the shaft for the scoops, would lock down into it. So the scoops, you're really only looking at the 1-inch shaft for the scoops, you know, maybe 7 feet total length. This one that I have here, I believe, is 7 feet. So if you lock down into the shaft below for the generator, maybe it only needs to be, okay, let me back up. If out of the generator, you've got your larger shaft, the hollow shaft, coming up to a height of 8-9 feet to get it above people's heads, then this would lock down into that and be connected with a pin or something so that it doesn't turn or anything like that. You would only have this smaller shaft, you know, the 1-inch diameter cold rolled steel shaft, for 6 feet. So I'm not worried about it bending or anything like that, because you can go as heavy as you want with coming off the generator to take care of that. It's not going to be this for a whole 15 feet, because yeah, I think that would pose problems if this was the size of the shaft for 15 feet tall. But we can be something, you know, 2 inches in diameter, hollow tube, you know, cold rolled hollow steel tube or something like that, that this would lock down into, and then you only have the smaller 1-inch shaft from, you know, 9-10 feet up in the air up to the top of the scoops. Hopefully that makes sense what I'm saying. Oh, yeah, I mean, obviously we're going to have to put good bearings in this thing, but we're looking to make the bearings hefty and, you know, heavy duty so that we can handle the lateral forces that the wind would create. Yes, I know what you're saying. And even up higher, you know, above the generator, you could go up a couple feet and then have more supports coming off of that so that you take the lateral force. So there's a bunch of different ways to do that. Hi, Harold. I'm going to put this shaft back because it's heavy. Let me answer your question then. So have I studied other vertical wind solutions, and would I summarize how mine would outshine them? Yeah, I've studied a lot of other wind solutions, and I'm not happy with any of them. There should be a lot more. You'll have to explain that while I'm answering Harold, Chris, if you can explain your question better or your statement there. But Harold, sure, I've studied a ton of different designs, and that's why I developed Harmony VAWT, because I'm not happy with what's out there. Right now, people are paying $30,000, $40,000, even $60,000 for a wind turbine solution that's, in my opinion, it shouldn't even be sold on the market. You know, they're trying to say, oh, it's a 15 kilowatt generator, but what they're failing to tell people is you've got you're coming out of zero wind speed with no production, and then as the wind speed goes up, it's ramping up and up and up to the peak production that the horizontal axis wind turbines are rated for. As soon as you hit the peak wind speed, let's say it's 20 miles per hour, you're making a ton of power, you're making a ton of juice, no doubt about it. But what happens when you go even just a couple miles per hour above that peak wind speed? Your production drops off drastically. It drops off drastically with those solutions that are out there right now. And why? Because they've got to dump their load, they've got to start using a physical disc brake or some other means of braking to keep themselves from blowing up. And as soon as you start dumping that load or braking or slowing down by those means, your production goes down into the toilet. With Harmony, all it's going to do is furl up a little bit, but it's going to keep spinning at its top rated speed. So with Harmony, it's going to go up until you hit your, peak wind speed or your desired wind speed, and you're at your maximum RPMs, and then it's going to level off. And Harmony is going to go flat line for who knows? I mean, obviously, until we get into real testing, we'll be able to determine what the destruction speeds are, but you're going to have a flat line at the top, which is amazing compared to what the other turbines do. The other turbines, they go up and then they come down just as fast. And you can only get those numbers that they're trying to sell you on. They're trying to sell you that big $60,000 system when your wind is in that very little tiny narrow band. When is wind ever going to behave like that? All I have to do is get up to the wind speed that I desire, and anything above it's fine. That's pretty cool. So yeah, Harold, I have studied a lot of other wind turbine solutions. The vertical ones and the horizontal ones both behave the same way with those ugly peaks like what I've been describing. There are a few out there that do some things with, they try and articulate at different wind speeds and things like that. I'm not happy with any of the vertical axis designs out there right now, which is why I've developed this one, why I'm going forward with, a patent pending design that I have. Thanks, Chris. You get the thumbs up prize. There you go, Mark. That's exactly what I'm talking about. It's a flat line of max power. And yeah, okay. Maybe I was describing it poorly. I'm sorry. A flat line of max power, where the other ones, it's a sharp peak and it drops off instantly after you're past their peak wind or desired wind speed. With Harmony, you're not going to have that. It's going to be a flat line max power production. Oh, you were saying there should be a lot more thumbs up. I understand now, Chris. Harold, have I answered your question? The other thing you missed, unless you were listening 15 minutes ago, I was talking about Harmony has its patent pending for both the turbine scoops and the generator technology. I have not released anything yet to the public really about the generator technology, save 90 seconds, maybe 2 minutes that I talk about the generator early on. I've got a generator design that's going to blow you guys away. When you finally see it, it's just as cool, if not cooler, than what the turbine scoops are. So initially, I'm just going to roll Harmony out, get the funding off the ground, get the serious investors on board to help get the startup, get our location, get a little manufacturing facility, and start getting these things out into beta test sites based on the scoop technology. We can couple them with off-the-shelf generators in the beginning just to get our data. Then while they're out in a dozen beta test sites and we're gathering data and we're back in the shop, we're going to be working hard on finalizing the generator technology, because my dream is to couple my scoop technology with our very own generator design. And that generator design, it's going to kick ass. When you see it, it's going to really, really twist your hair when you see what it does. So a teaser on that is we're going to be using solid core coils. Right now, the industry solves the cogging problem where you have, you know, the magnets and the coils locking up and not wanting to move. They solve that by doing air coils. I'm not using air coils. And I'm not doing some crazy weird offset thingy, whatever. I'm solving the cogging issue in a very unique and different way that's going to allow Harmony to have very low wind startup speeds, and then with the generator handling the low end startup speeds and the scoops handling the high end because of their furling, you're going to have an amazing end product, all for the bargain basement price of, I'm hoping, somewhere in the neighborhood of $8,000. And your payback, 5 years, 7 years, somewhere in that neighborhood. I mean, after a year or two of having this and you start seeing the payback you're getting on your electric bill, I think a lot of people are going to be like, you know what? Let's buy another one or even two more, because this little thing is it's going to change the way we think about wind turbine technology. Right now, people are asking me, well, how do you want to compete with solar? You know, how do you plan on competing with solar? Why in the world would you want to compete with solar? That's the most ridiculous thing I ever heard. They're both going to dump into the same source. When the sun is shining, you don't usually have wind. But when the sun's not shining and it's cloudy, it's windy. So the two are usually doing this. Dump them into the same source. You've got your solar when it's sunny. You've got your wind when it's windy. Your wind power when it's windy. It makes absolute perfect sense to couple these together. You know, maybe one day when I'm big enough and have the company off the ground, maybe I'll see if I can get a meeting with Tesla or something to couple with technology they have. Maybe they'll look at what we have and say, wow, that's pretty ingenious there. So I don't know. It'd be great to work with a company that's doing the solar shingles and dumping into a power bank. I'd love to see that power bank become capacitors, supercapacitors, and ultracapacitors. But that technology is still 5-10 years away before we're really down to the power densities, or up to the power densities that we need for capacitors. Thanks, Douglas. Teasing you more with the talk of the generator, Mark? Harold, I am too. You know, I'm really excited to see the grassroots solution. Thank you. I am looking to maybe do a Kickstarter after we get a little further down the road. I want to have something real, something that I can actually put in people's hands before we start, you know, throwing a lot of promises out there. I'm the kind of guy who builds. I build, I get my hands dirty. They're dirty right now, you can see. I don't talk. Talk is cheap. I build and I demonstrate and I do things in a way that other people can verify the results. So that's what I've always done for the last 20 years as I've been working on clean energy tech, and I'm going to keep doing it with this. It's just, you can't necessarily build this to verify it, but when I start getting them out and in beta test mode, you'll be able to verify them that way. You know, I'll have people who have been screaming and wanting these for the past year, and we'll be installing them at those locations so that people can get the results and can see the numbers. You know, until that first prototype is built and I get the numbers, it's scary. You know, I have to say, I am worried that the production's going to be lower than I'm expecting or hoping, but I can't think that way. You know, there's so many good things about it. I'm going to keep my hopes up that when we put the prototype into production and we see the numbers, it's going to blow my socks off. So I'm going to keep, you know, hoping that that's the outcome. And if it's not, I'll adjust. Maybe I need to go a little bit wider. Maybe I need to do a 6th or a 7th scoop pair. Who cares? You know, those are engineering problems that can be addressed. Production is really just a matter of swept area. And, you know, with this design, you've got some really, really intuitive pieces to it that solve a lot of problems that are out there. One of the things that I do, you know, I don't really have a good solution for it right now other than to say it'll be some kind of heat tape solution in the gears, but ice and snow would definitely be a problem. So if you guys want to help me think about cool solutions for how to keep the ice and snow off, resistance heating is really what I thought of, but it gets into a pretty ugly problem. Obviously, if the turbine's spinning and producing power, we'll have power to do resistance heating, but maybe these just aren't the solution for the northern territories where you're going to have real bad icing and snow conditions, and so be it. If it is, it is. That doesn't bother me if we can't put it in the northernmost applications. Okay, it might remove some of the worldwide market, but it's not the end of the world. I have gears. It's going to need to furl. There's going to be moving parts, and yeah, ice would be a problem, but there's a lot of creative people out there like yourselves. I'm thinking we can come up with some pretty cool solutions to the icing issue if it comes down to that, if we really need to. But right now I'm not worrying about it. I'm not wasting time on it. The simple solution is I'm just avoiding that market for the time being. And hopefully that's not a detraction. The prototype experience, I like that. All right, guys. Well, I have been live streaming for I don't even know how long. It's been a while, so I'm probably going to cut this off at this point. Any last questions? Oh, it looks like about an hour. Wow. Any last questions that anyone has quick? Bearings between the scoops and the shaft and lock when it's... Oh, you're saying allow them to slip at higher winds. There's no need for that, Harold, because if they can furl up. Have you seen the videos of how they furl and close? Hey, Matt, how's it going? I like the hydrophobic coating, but I don't know that that would stop snow getting in and then the snow settling in places kind of turning to ice, or it rains and it gets caught in areas and then it drops down below freezing. We're going to deal with the icing later. Let's worry about getting the prototype out the door in the, in the warmer than freezing climates and get a good product, and then we can deal with the icing. It's just an engineering challenge. It's not anything that's going to sink the ship by any means. And there's some great wind in the cold territories, so I would love to tackle that, but maybe that's a job waiting for you, Matt. There's an offer. Harold, have you seen the videos where the turbine, it furls up and it closes up on itself? Okay, Mark, have a good night. Okay, I don't know. We can chat about that a little bit later on. If you're looking to if you don't think that the furling is going to be enough, I believe we're always going to want to drive the main shaft from the scoops. Even if the scoops are only 5 or 10% opened in a hurricane, who cares? You're still producing power right on through that hurricane where the other 10 turbines down the road have been destroyed or, are laying on the ground. Harmony can keep spinning right through that hurricane. That's the hope, at least. Oh, Chris, yeah, let's not worry about the snow and ice right now. Maybe I shouldn't have even brought it up. I don't want to detract from the design just because of a problem that all wind turbines face. They all have to deal with ice and snow, and it's all, in many cases, an ugly problem. So I'm not going to worry about it right now. I'm not going to detract from the momentum we have with putting this together and getting the turbines going, getting the prototype going. Hi, Doug. No, it's actually going to be probably something like a Raspberry Pi or an Arduino. It's going to be monitoring RPMs, and as it approaches its maximum safe RPM limit, it's going to begin furling off of that algorithm. So it's going to be a continually looping algorithm saying, am I above my safe RPM limit? And if yes, then it's going to start furling a little bit. And as it keeps checking, it'll say, okay, now I've come down and I'm in my safe limit, so I can hold at this, maybe it's 80% opened at that point. And it's sitting there spinning happily. It'll keep doing that adjustment continuously, all the time. And then when the wind speed starts dropping off, it would detect that it's dropping below its desired RPM limit, so it would begin to open back up. So it's just going to be a simple RPM algorithm. It may be coupled with performance algorithms, because as I get the prototype and start testing it, maybe I'm going to find that 100% open is not the most efficient. Have you ever seen a skater pull their limbs in, and when they're rotating, an ice skater starts spinning faster and faster and faster? Well, there might be a sweet spot here where 100% open is not the best. Maybe in certain, as I graph it in a 5-mile-an-hour wind, in a 7-mile-an-hour wind, in a 10-mile-an-hour wind, we might find that particular wind speeds are performing better with slightly closed scoops. So that'll be all built into the algorithm, so that as it's spinning in the wind conditions, in the certain wind speeds, it would be furled to its optimum open state. Harold, there's no, the scoops come together so easily. If you look at my older videos, I'm sitting there with 2 fingers turning the furling, what I call the furling tube. It's really just a 1-inch piece of PVC to spin the furling tube. You have to remember that the scoops are constantly turning away from the wind. So it's not like they're going to be, it's not like you going outside with a tube, a piece of plywood, and you're like getting buffeted by the wind. These scoops are constantly turning away from the wind. So for it to begin furling, even though they're being driven by the wind, it's not going to take a lot of power. And they're going to be driven by a worm gear. So that worm gear has a tremendous amount of torque. The awesome part about it is once the furling is at a point where it's done furling, the power is turned off to that stepper motor, and it doesn't need any power to hold the furling right at that position, because a worm gear locks against the, what are they called? Just your normal, I can't even think of the name of them. Your normal, it starts with an S. No, not a reduction gear. I'll think of it 2 seconds after we stop talking about it. But your normal straight gears, and then a worm gear engaging it from the side. Those gears, basically, if the worm gear is spinning in this direction and it engages the gear teeth from the side, that gear is locked. It can't move when the worm gear stops spinning. It holds the other gear. Oh my God, I can't believe I can't think of the name for it. Not a stud gear, I don't know, I can't think of the names. Not a spline gear, I'm sorry. It's just your regular standard gears, like your normal 2-dimensional gears that you think of. They've got a profile, but there's no real 3D curvature or anything to them. It's just a 2D profile that's extruded upward, and I can't think of what they're called. Not a spline gear, not a sprocket, I can't even think. But anyway, the worm gear engages with that gear at a 90-degree angle. So as the worm gear rotates, it would slowly turn the furling shaft to furl all the scoops together. And then as soon as that motor shuts off, it doesn't need any power to hold the scoops right at the furling degree that they were at. I can't think of the name of it. I'm not going to worry about it. But at any rate, yeah, when that furling action takes place, it's not going to be something that's going to require a great big stepper motor to do it. It's just going to be a little, maybe a NEMA 17 motor or something on the very bottom of the scoop array, and it's going to be able to furl all the scoops, opening and closing them pretty much effortlessly. Okay. Yeah, Doug, the balls to the wall kind of centrifuge, they've got the ball governors and things like that. That's not going to be necessary with the furling. In fact, it's far more complicated than it needs to be. It's just going to be, if you look at, I know it's a little bit silly to tell you to go look at my Foundry videos, and you'll see I've got a worm, it's called a worm winch. it's a worm gear engaging a normal tangent gear, and maybe the steampunk version, I like it. But basically, when I spin that worm gear, I can use 2 fingers to turn my 300 pounds as the foundry pot is being tilted and pouring molten metal. And at any moment, I can stop, I can let go of it, and that pot, whatever angle it was at, just holds right there. And that's because of the way the worm gear engages that, the other word I can't think of for the gear type. Maybe I should look here. Gear types. Man, I feel so stupid. Spur gear. There it is. Spur gear. I'm so sorry. So as the worm gear engages that spur gear is just held perfectly still when the worm gear stops spinning. And the same thing's going to happen in the furling action of Harmony. As soon as it's furling down and it gets to the point where it wants, it stops, and the power to that stepper motor can be turned off, and there's no more power wasted just to hold the furling action. It's also going to mean there's very, very, very little power required to furl all of the scoops at the same time. Yeah, it is. It's all about gear reduction. A worm gear is usually like a 30-to-1 or 50-to-1 ratio in and of itself. So that makes the furling action is going to be slow, but you don't want it to be fast. You know, it's going to be constantly monitoring RPMs, and yeah, you do get gusting sometimes, but Harmony's not going to be built so fragile that it's going to just blow apart. It's going to be able to take gusting, and it'll start furling down as soon as it sees, ooh, I'm at an RPM that I don't want to be at. It's going to start furling, and it's going to keep furling until those RPMs have dropped down to a safe limit. All right, guys. Well, my throat is starting to get raw from talking, and I've definitely been going longer than an hour now, an hour and 7 minutes. So you're welcome, Doug. Thank you. Thank you, Harold. Thank you, Chris and Mark. I think I've called out everyone as I scroll up here, and Go Vertical. It's too bad I can't see who is actually online. I just see 7. But that's cool. You guys have been great. All right. Mark, I thought you were you're supposed to be in bed, man. All right. Take care, guys. Thank you very much. Peace out from Harmony VAWT. How do I shut this crazy thing off? Oh, yeah, up here.